As an AI engineer in fintech, I've been recently working with a very specific workflow in accountancy context. And what I've learned from one of the best companies right now in the accountancy space is that your reasoning is probably your most important asset that you have, because given the landscape of ever changing tools, frameworks, the languages, you just cannot rely too much upon these specific tools and these specific assumptions. So what is one of the two things that I've noted down is the first one is I like to approach problems when two ways. The first one is first principles. So basically, instead of making assumptions, you refuse to make them. And so basically, instead of asking how is it normally done, you're asking what is actually true here and what follows from that. What is optional? And when you know what must be true and what is optional, then you will know everything in between. You'll find a way out. If you know the input, output, you will know how to find whatever sits in between. And the very important things here is that separating physics from convention, and I say that because I've taken notes on the laptop while I was doing that, because when I was going through of my README, something clicked, because there are a lot of practices that people are actually real and people adopt them. For example, you must watch the latency, you must watch the token usage, you must watch the cost, you must do some audit trails, etc. And there are practices like that are inherited assumptions, like you must connect this to that database, you must do structure agents that way, you don't have to do this or that. And so the risk here is that your reasoning ability is very slow comparing to this landscape of frameworks and tools that go with agentic AI right now, that evolve from there, that stem from there. And you cannot, very important thing is that you cannot first principle everything. You just cannot, because sometimes you need to borrow a solution to just get it done. And that's the thing that I've been thinking. And the second one is the inversion problem. Inversion, that Charlie Munger, he said it very perfectly: invert, always invert. And he basically said this: tell me how, where am I going to die, so I will not go there. I think that's brilliant. And so when it comes to inversion, you should always ask yourself, when you've broken down everything from first principles, you can, it's not mandatory, but you can ask yourself, and in many cases it will help, that what do I need to do for this to break? And when you know how to break the thing, then everything that's left, when you've gone through every possible scenario that you can think of, at least at this stage of your thinking, how can this be broken? Then everything that's left is probably if not the solution, then the path that will lead you to the solution. And so it's very important to understand that these things, like first principles and the inversion theory, they are complementary. They're not interchangeable. So these are the things that I've learned, and honestly, I've never thought that I'm gonna say this, but writing good README markdown files is so important, like you could never imagine. So write good READMEs.